Okay, the next topic is IRR and ERR method for engineering economy. Okay, what is IRR? Is internal rate of return, and then ERR is external rate of return. Okay, IRR method, this is several detail of IRR method, where is most widely used rate of return for performance engineering economy analysis. So means that this is the rate that you need to know in order to you decide which is worth or not to do the business or to do the investment. So also known as investor methods, where is the discount cash flow method and the profitability index. That is solve the interest rate that equates the equivalent worth of alternative cash flow, receipt of saving, to equivalent worth of cash flow, expenditure, including investor and cost, and break even and interest and C. So this is about internal rate of returns. So this is an the formula of rate of returns, where is using, for example, present worth formulation. So RK is a net revenue of saving of K year. EK is net expenditure including any investment cost for K years, and N is project life or study periods. So in order to make a decision, the rule is if your IRR is better or equal to MARR, minimum acceptable rate of return, so the project or economically justified. I mean, it worth for you to take the risk, of investment. Okay, so if you can see this plot, so it's for an alternative single investment cost of present time followed by a series of positive cash flow inflow for N. So a graph is PW versus the interest rate typical has the general convex form. So if you can see if the P is positive until one moment, the I value will be 0, and that's the break even area lah, is worth for the investment. So the point of PV0 define I percent, which the project IR, the value of I percent can also determine the interest of at which your future value equal to 0 or annual worth equal to 0. So that's the point where you decide this is the worst IRR or investment for your business. So the investment balance diagram shows on the y-axis is unrecovered investment balance, and the right is years. So if you can see that this graph shows the original investment of alternative, which is still to be recovered as a function time. So the downward arrows represent annual returns. Okay, downward is annual returns, RK minus EK for K between 1 to 1N, any type of years, against the unrecovered investment, and the dashed line indicate the opportunity of cost, interest, profit, and beginning of investment. So if you can see here, okay, if you can see here, so what happened is, for example, in the first year, so you notice that the dotted is increasing, means that opportunity and cost increase and profit start increase. Until one moment, we notice that it will be reduced of downward arrows of represent the annual return, then keep on increasing and return. So R should be in the salvage market. So this is the initial investment, and throughout the year, so the unrecovered investment start to be reduced. So it's showing if you want to invest something or something, it will take, the best is it will take several years. It's not like short-term investment of projects. Okay, if you want to buy a machine, you cannot expect the machine will give you a positive rate of investment within 1 year. It should be 3 to 5 years or ahead. Okay, so we go example. For example, this MT is considered to purchase a digital camera for maintenance of the design specification by feeding digital picture direct to the engineering workstation, where computer-aided design file can be superimposed over digital picture. So difference between the two images can be noted, and correction as appropriate then be made by designers. Okay, we go for here. the capital investment okay, the capital investment required 345. It should be an investment cost, which is negative lah in your cash flow. And the estimate market value of system will be 6 years period of 115. After 6 periods, there's a market value. And annual revenue attribute to the new camera is 120, where additional annual expenses will be 22 thousands. So you've been asked by the management to determine the IR of the project and make a recommendation. So the corporation of MARR is 20%. Solve first by using linear interpolations, by using spreadsheet or others method. So for example, for this cash flow, the positive sum cash flow is 835, exceed the sum in cash flow of 455. So thus like that, the positive IR can be determined. Okay, by writing in term of equation is, okay, so we expect that your present worth will become zero, whereas this is your cost investment is about negative 345, then plus for your annual present worth is about 120,000 minus 22,000 for the 6 years, and plus 155,000 for the future value. Okay, for example, we go for the cash flow. The cash flow will be like something like this. Okay, so you will have a negative, okay, 345 so then you have about 6 years of okay, this one will be about 120 minus 22. Okay, then at the end of the year, it's a future where about 115k. After 6 years this one 6 years. Okay, so what is your I%? So in this case, you need to predict, okay, you need to calculate. For present worth is 0. This is a formula. So you need to try and error with starting about 20%, for example. When you put 20%, you will get positive 19. So we want it to be near to 0. So then since PW is positive of 20%, so we need to increase the I% should be higher lah to get the in between. Where is the correct one? When we put it 25%, what we get is a negative value of $25. So it means that the value is between these both of this one. Okay, so what you need to do, you need to do in the interpolations. So from the graph, okay, we go for the graph. So we have a value of 19,000. So we reach the positive of 20%, and negative 25,000 is a negative of 25. Is a 25% of. So we want to get the I value at between. So you need to do the interpolations. You cannot divert, divide it. So it means 25% minus 20% divided by 19,000 divided by negative 25%. So I% minus 20%, because the 20% will be your benchmark. So of 90% divided off PW is 0. So at the end you get 22.60%. So in this case, your IRR is 22.16%, which is greater than your MARR. Where is your MARR is about 20%. So this project is acceptable to be conducted or to be invest. So you need to check your IRR must be positive value higher than MARR. If not higher, you decided that's not a worth for IRR investment lah. So installment financial arrangement to purchase merchandise on time instead of unpaid loan balance. Total increase charge is on the basis of is also owed of the beginning. So lead the actual interest rate, which is a higher and bigger than initial state of rate, which is IRR is used to determine the true interest. Okay, if you go example, there is a small airline executive chartered company need to borrow 160,000. A local bank, we can loan you about 160,000 at the favorable of 12% per year in 5 years. However, to secure this loan, you must open a check account, no interest, with the minimum balance of 32,000. So you need to have a cash of 30,000 in order for you to get the loans. So your interest payment are due at the end of each year and principal lump sum at 5 years. So what is the true annual interest rate? Okay, step number 1, you need to know cash flow. So in this case, the company want to lend 128,000, 660,000, but they need to have money of 32,000 in order for them to get the loan. So means total of P note is about 128,000. And then the interest, the favorable interest is about 12,000 per year in 5 years. So your annual will be 12,000, 0.12 times 160 is 19,200 for about 5 years. Yeah, at the end of 5 years, you will get the future value is about 128,000. So in this case, what is your best IRR? So we use this formula. So for example, we want P note is equal to F5 for P over F, I percent 5% plus A, P over A, I percent 5%, I prime 5%. So your present worth is about 128,000. Your future worth is about 128,000. Use the P over F formula. And 19,000 is an annual, or A, P over A. So in this case, this is your formula. So you need to try to find which is I percent. For example, is 15%. So we discover is 128,000 is equal to 0. So therefore, the true IRR rate is about 15% per year. Okay. So difficulty of IR is one is computational difficulty. Second is occurrence of multiple IR at once in a certain problem. Multiple rates are not meaningful in decision making. And